What's going on, people? Welcome to a day in the life of an overhead line design engineer in the UK. Basically, I help design the power lines that keep your lights on, and today I'm out on site looking at a possible grid connection for a solar farm. It's not just about standing and looking at towers all day. It's about understanding the terrain, checking structure conditions, and figuring out the safest and most efficient way to bring renewable energy into our system. But before we get into it, let me just give you a breakdown of what overhead line design engineering is, and then let me show you how it all comes together. So what is overhead line design engineering? It's sort of an amalgamation, right? Imagine you had a pot, trying to make a stew, right? The final product will be an overhead line design engineer. But in this pot, you're going to be putting, electrical engineering, you're going to be putting mechanical engineering, civil engineering, structural engineering, and then you're going to mix it all together, all right, in this giant pot, okay? And in the end, once it's all cooked and ready to serve, you'll have an overhead line design engineer. As an electrical engineer, or someone who has an electrical engineering background, you will be able to advise us on things such as insulation, conductor type, right? You're transporting electrical current from point B to C, yeah? You can advise us on things like lightning protection methods. In an event of a lightning strike, what do we do? Earthing and all that good stuff, right? Short circuit loads as well. For a mechanical engineer, you are somebody who's going to give us the ins and outs of the components, right? The mechanical properties of equipment. So think conductors, right? You are going to understand the relationship between the unit weight per meter, the ultimate tensile strength, right? The cross-sectional area, the modulus of elasticity, the thermal coefficient of expansion, or the thermal expansion coefficient, however you want to coin it, right? And the relationship between the load, right? The load being the current that's flowing through the conductor, and the material type, right? How much is it going to sag? How much tension is it going to be in the conductor, right? Is it going to anneal? And all of that good stuff, right? All these different stress and strain curves, and you get me, all that side of engineering. Your civil engineer, is going to deal with things such as surveying the site, looking at terrain conditions, the foundation type, access roads, how you're going to get onto site, how you're going to get off site, traffic management, that side of things, right? Your structural engineer, well, that one's a bit more obvious. How is this tower, this lattice tower, right, going to stay upright? How is this wood pole going to stay upright? Okay. Subjugated to all these different loads, your wind, your ice, your dead loads, your variable loads, your short circuit loads, all these different type of loads being applied to this tower or this infrastructure. Your structural engineer is concerned with how to sort of mitigate it in the event of, something crazy happening to it, or, how to strengthen it following this crazy event, right? Or this failing event, or the event of something going wrong. So that is pretty much what an overhead line design engineer is. I'm going to go a step further, actually, and I'm going to give you guys some actual insight. I'm going to take you guys with me. Yes, you're going to come with me on a journey to a site visit. It's about 3 hours away from where I am now. So I'm going to see you guys very, very soon. And what I'll show you is, the towers we're looking at, what suite they are, explain to you the site conditions from what I've noticed from this sort of walkover that we're going to conduct. Show you some fittings, conductors, insulators, right? Explain to you what voltages we're dealing with, right? And the whole purpose of the site visit, why we're going to site in the first place. It's a point of connection scheme. What is a point of connection scheme, right? We'll look at some of the tower steelwork, do a little condition assessment, ground level, very basic stuff, just to give you guys a feel of what a overhead line design engineer does. Now, this is not on a regular basis, so you're lucky, right? Most of the time, 99% of the time, I'm sat on my backside and I'm using software, keyboard and a mouse, and writing up reports, dealing with clients, teams, and all that good stuff. So you're actually lucky. Count yourself lucky that you're going to see some real behind the scenes footage of an overhead line design engineer. So I'll see you guys in 5. Okay, we finally made it to site. First thing we done was we touched base with the client, set up a plan for the day, touched up on some key points, things that he would like us to cover. And here I am just giving you guys a quick shot. There's some overhead line conductors. This is a PL-16 type tower, and we're just having a look right now to verify it's the right tower, the right site. You know, you can't always rely on as-built information. It's always good to get close and personal and verify circuit IDs and, you know, tower number plates and all that good stuff. Now, usually I don't like going out on site, but today was a really good day. I mean, the sun was shining, it was clear skies, and you know, looking at all that livestock, I feel like I'm in Age of Empires. Okay, boots on, sunglasses on, high vis on, gloves on, ready to do the site walkover. So, we've come close to a tower that we consider the point of connection from. So I'm just looking around at the terrain, making sure that the ground conditions are suitable for this point of connection. And, you know, just getting a close-up at the tower, looking at its condition. You know, is it in good nick? Has it had a recent paint job? Are there any bent bars, bent members, things I need to be wary of? So we're just doing a few close-up shots. This is called a visual ground inspection. Now, if I did spot any red flags, I then would advise the client to carry out a tower climbing inspection. This will consist of somebody actually climbing the tower, keeping note of all the bent, rust, and corrosion that they spot across the tower. And then we'll be able to take this information back to the client and advise them on what to do next. Do we either strengthen it before we carry out our design work, or take it into account during our analysis work? Okay, so based on my engineering judgment here, this tower's in good nick. It looks like it's been painted recently. I don't see any signs of rust, corrosion, or bending of any members, so it's all systems go. Okay, so now that we're back in the lab, I can show you guys this exact tower, this exact PL-16 D2S E10 extension tower in the form of a numerical model. This software we're using is called PLS-CADD and PLS-TOWER. It is the backbone of the overhead line design industry. It's used in more than 125 countries. I think it's fair to say that without it, we would be doomed. So I've just clicked run, as you can see, and now I'm just trying to identify, you know, are any members failing, are any bolts failing, you know, what is it being governed by, which load case is governing, that sort of thing. This is a table that shows you all of the members, all of its properties, its steel grade, and lets you know, yeah, what sort of loading criteria is governing. Could it be the high wind? Could it be the heavy ice case? You know, is it below 100%? If it's above 100%, what sort of things do we need to do? And all that good stuff. So now I'm going to display the PLS-CADD wires, or the conductors in real life, and I'm going to run through the load cases. And this is the fun part, the visual part, and you will see that, you know, when it's subjugated to high wind or combined wind and ice or a broken wire case, how the conductor system and how the tower will react to those loads visually. So I'm just going through them right now. I'm pressing F6 on my keyboard, and you can see the tower dancing from left to right. So again, as we can see, all the bars are below 100% utilization. This is a really good sign. So I'm hoping that when we do add the point of connection, you know, whether it be to a pole, to a gantry, to a point of connection mast, you know, the tower will be able to withstand the loads. That wraps up things. Now, hopefully you would have gained a lot more of an understanding, a bit more depth as to what an overhead line design engineer is and what they do, right? You know, it's a very limited view and perspective that I'm giving you guys. Of course, we do a lot more than this, but, you know, it will just be information overload. If you guys are really interested and you guys like the videos more, I can give you guys a bit more of a detailed breakdown, show you some more of the software and whatever things the software can do, you know, show you an example of a report that I produce, right? You know, maybe enact some scenarios of me dealing with clients. You know, might get a whiteboard behind me, give you guys some first principles, a lesson on first principles, right? How my university degree has or has not helped me in this stage of my career, right? I can make it a bit more interactive, a bit more educational. But for now, just wanted to give you guys a bit of flavor, yeah, something to season, you know, you're engaging with other people and stuff like that. Just to explain that, you understand what an overhead line design engineer does. And, you might meet somebody, you might have now some common ground, right? You can ask them a few more questions, right? And, oh, is that what you guys do? So this is how you strengthen a 50 by 50 by 5 member. Oh, okay, I didn't know that. If it's failing in compression, this is what you guys usually do, right? Is it you'd add a bracing, for instance, or if it's failing in tension, would you look at the bolts? Would you add more bolts? Oh, I never really visualized it like that. I always thought, these towers are just put up there. I don't really question why or how they got put up there and what they actually do. So, giving you guys an insight at the end of the day. You can take it, you can leave it, but I've done my part. Thank you very much, everyone, for listening to today's video. If you liked it, like, comment, subscribe. If you have any questions, please let me know down below. Thank you very much. Peace.